My guest today is one of the few credentialed electrical engineers in the world who has spent nearly 2 decades doing what many scientists will not, rigorously investigating a phenomenon that mainstream physics has largely declined to engage with: ball lightning. Thousands of eyewitness accounts spanning centuries. No consensus theory, no reliable laboratory reproduction, yet it keeps appearing. Dr. Karl Stephan is a professor of electrical engineering at Texas State University's Ingram School of Engineering. He holds a BS from Caltech, a Master's of Engineering from Cornell, and a PhD in electrical engineering from the University of Texas at Austin. He has received a Julian Schwinger Foundation grant for research into plasma-enclosed waveguides, conducted funded research into hydrogen spectra in water-bearing plasmoids, and co-published a landmark 2025 paper in the Quarterly Journal of the Royal Meteorological Society analyzing video evidence of possible ball lightning, frame by frame, and concluding the footage was likely electrical arcs rather than the phenomena itself. That willingness to disprove as rigorously as he investigates is what defines his approach. He and his collaborator, Richard Sonnefeld, have also collected over 1,000 eyewitness accounts through a public reporting forum they launched in 2020, building a citizen science data set that instruments alone could never reproduce. As a primary witness to the 2004 Princeton Tic Tac UAP encounter, I know what it feels like to watch instrumented systems record something your framework cannot explain. Dr. Stephan has spent his career approaching the same problem from the other direction, building the instruments, running the analysis, and refusing to call something proven until the data says so. Dr. Stephan, welcome to the experience.
Thanks for having me.
I've really looked forward to this interview today. Of all of the people I intend to talk to, your research is some of the most fascinating that we have on record and that we treat as science, if that makes sense. I'm very curious what closed the gap for you between curiosity and a professional commitment to ball lightning. I can see what might have interested you in it, but what was the thing that nailed it for you that said, I'm going to dedicate myself to doing this?
Well, I would say the fact that people started attempting to reproduce ball lightning in the laboratory, and these attempts were something that you could reproduce.
Mhm.
The issue of ball lightning, of course, is limited by the fact that you can't go to a particular place and count on it showing up.
Mhm.
When it shows up, it doesn't last very long, matter of seconds. And so most of what we know about ball lightning is from eyewitness accounts rather than any kind of objective instrumentation that, would look the same to everybody else.
Mhm.
Uh, so it's very difficult to do what I'd call direct observational research in ball lightning. However, when people do a laboratory experiment, which they claim to be ball lightning, then if you can reproduce their experiment, you can compare what the experiment really does to the body of observational knowledge that we have from eyewitnesses.
Mhm.
And this is not a popular thing to do. I mean, in the sense that, everybody's looking to actually find out what it is, and that's fine.
Mhm.
But when people make claims that are what you might say uh, more ambitious or more positive than the evidence allows, somebody needs to go around and say, well, wait a minute, you know,
Mhm.
uh, because as you pointed out in your very good introduction, which saved me several minutes of talking, uh, the bulk of the scientific community is simply ignoring ball lightning.
Mhm.
Uh, Nevertheless, the people who are paying attention to it are highly motivated to find out what it is. And when they find either observational evidence or they do an experiment which resembles ball lightning, they have every right to publish something and ask the question, is this ball lightning?
Mhm.
That's a perfectly legitimate question. But answering the question requires typically further research, including trying to reproduce the results. And then, based on what's really going on, saying, yes, you have finally made the discovery, or actually what's going on is this and that kind of conventional physics. And the thing that opened the door for me was about 20, 22 years ago, some Israeli researchers published a paper which related a phenomenon in a microwave waveguide to ball lightning. They didn't say, hey, we have discovered ball lightning. They were more conservative than that. But they did demonstrate this interesting phenomenon. And I happened to be working with a colleague who had basically the same equipment that they were using, a high power microwave generator, sort of a super microwave oven without the oven. And so we put together the fairly simple auxiliary equipment we needed to reproduce their results. And we did. And what we published was a paper that explained what was going on in terms of conventional fluid dynamics and microwave effects that have, in one form or another, been known since World War II. And, I wasn't criticizing them in that sense, but as I began to look into what ball lightning really was and found that there was a lot of observational data you could compare these experiments to, it seemed to me that somebody needed to go around looking at, experiments claiming to be ball lightning, reproducing them, and, giving a second opinion, shall we say, of whether or not this really is the case. And that's really what I've been doing the last 20 years
Yeah.
in terms of experiments. There have been, I could list 3 or 4 other different experiments that, mention ball lightning in various degrees or to various, confidence levels, shall we say. And each one of them turned out to be something that was interesting, certainly, but was not likely to be what ball lightning really is. So that's how I got interested in it professionally. Also, having tenure helps because there's no chairs of ball lightning studies that I'm aware of. So you have to kind of take a privilege of as long as I'm doing research and it's somewhere in my field, I don't think they're going to bother me. So that's more or less. And they have been very generous at my institution to let me do this kind of thing without trying to steer me in any particular direction.
That brings me to a question I feel some of my audience might be asking right now, not even realizing they hadn't really asked it before. But what is ball lightning?
Well, the best way to answer that is to describe what I would call a typical ball lightning sighting. And this is a compilation of, hundreds of reports that I've read over the years. Typically, not always, a thunderstorm will be in progress somewhere in the vicinity. That could be anywhere from directly overhead to miles away. At some point, the eyewitness, because most of these data are from eyewitnesses, will see a glow, perhaps out of the corner of their eye, maybe right in front of them. This glow will be a spherical object, not perfectly spherical all the time, but between the size of a baseball and a basketball, maybe a little bigger. It won't be terribly bright, maybe about the brightness of a 100-watt incandescent bulb. It will not be moving very fast, although sometimes it's hard to tell how fast it's moving depending on how far it is. It may be outside, it may be just outside your window, it may be inside the room. We've had dozens of reports of ball lightning appearing inside houses, and as you mentioned, airplanes and so forth. Anyway, this thing shows up. It typically moves in a horizontal direction if it's close enough to be witnessed by somebody who can see how big it is and see objects that are behind it so that they know it's not any farther than the stationary objects behind it. It doesn't move very fast, maybe 3 or 4 feet per second, typically, sometimes faster. Sometimes it goes out of sight, and that's the last people see of it. Sometimes it vanishes. Sometimes it goes into a wall and disappears. Sometimes it explodes with various degrees of damage. This is what I call a typical ball lightning sighting. And since most of what we know is just empirical observations, this is basically the best description I can give, which of course is what you call empirical. We don't know what it is, but we base what we know on what we see in this case, and that's what people see.
Now, a lot of times in a lot of general talk of the paranormal, the unknown, the fringes of science. People talk about ball lightning a lot in conjunction with UAP and things like that. And these days, a word is getting thrown out a lot, and I'd love to hear from an expert what is a plasmoid?
Okay, plasma is the fourth state of matter in which some of the atoms are ionized, or molecules are ionized. They've lost some of their electrons. They have a positive charge, and they're free electrons moving around. The most probably familiar plasma that people have seen, an actual genuine neon sign that has the little glass tube with the glowing stuff inside. The red glow is a plasma. It's a ionized gas that is highly electrically excited. A plasmoid is plasma in a shape of some kind, typically spherical, although not necessarily. Uh, Plasmoids can occur in, for example, semiconductor processing equipment. A student of mine once showed me a video of a large semiconductor processing chamber in which a large glowing sphere was rotating around, you know.
Mm-hmm.
And I thought, isn't that interesting? Uh, the way that plasmas turn into plasmoids has a lot to do with fluid dynamics, electrostatics, and lot of complicated physics that isn't particularly well understood because there are no commercial uses of plasmoids, as far as I know.
Mm-hmm.
Uh, but you know, a plasmoid is simply a region of plasma that's more or less self-contained. Now, the plasmoid I was talking about in the semiconductor processing equipment, they were continuously putting in power. They have to have a radio frequency power to make these plasmas in semiconductor processing. One of the big mysteries of ball lightning, which you could call a plasmoid, since if it is plasma, and we're pretty sure it is, but not
Mm-hmm.
positive, if it is a plasma, then it has a definite shape. It's legitimate to call it a plasmoid. The big mystery is, where is the energy coming from? Because any kind of plasma that you typically make for commercial or scientific purposes requires an input of energy, typically electrical, although not always. If you cut off that energy, a plasma will just go dark and cease to exist in fractions of a second, millisecond.
Mm-hmm.
Ball lightning doesn't do that. It hangs around for several seconds. And so, but that's what a plasmoid is. Made a long answer to a short question.
Mm-hmm. Well, I think that actually brings me closer to understanding. So, is there a would there so a ball lightning may be a plasmoid, or we're saying
It's
it's possible,
likely,
it's
not
likely.
certain.
Hmm.
Everything, nothing is certain about ball lightning, just about. But yeah, there are a lot of indications that it's some kind of a plasma.
Have we been able to derive or observe any internal structure to either of those two things?
Well, people have seen internal structure to ball lightning. There's a report from New York City that was published about 2000. A teenager was standing on a stairwell, and ball lightning came in through an open window and passed within about 2 or 3 feet of him. He saw very complicated little structures of uh, miniature sparks in a symmetrical pattern inside this thing. It's unlikely that somebody would just make that up, although it's possible. And other people, on occasion, pretty rare, but other people have seen that there's a brighter layer and a dimmer layer to it, or there seems to be some kind of internal structure. But again, that's all observation. If you look at theories published about ball lightning, there's all sorts of theories of what is going on inside and layers and this and that. But sticking to observations, there is some evidence that there's an internal structure, but uh, it's strictly, just somebody's observation. They happen to be close enough to see it, and a lot of other people don't see any structure at all. The object seems to be kind of opaque, really, and if there is anything inside deep within it, they wouldn't be able to see it.
Self-organizing luminous plasma phenomena seems to share behavioral signatures, duration, resistance to dissipation, apparent intentionality, and movement. What underlies the pattern? What links these things to you?
Well, you have to take all those separately.
Okay.
The apparent intentionality,
Hmm.
that's a little touchy there.
Sure.
Um, if it's plasmas, conventional plasmas can be what I would call very unstable things.
Hmm.
I have on my desk over here one of these little plasma orbs, less
Mm.
plasma, it's about the size of a light bulb. You can
Yeah.
buy them at museum stores, and they have little batteries that they plug in, and there's these glowing little wisps. Well, you just move your hand close to that thing, and the little wisps of colored, gas will attach to your finger.
Hmm.
So they're very sensitive to very slight changes in electric field or air currents. So if there was a self-sustaining plasma that was sustaining itself by some means, it doesn't surprise me that it would seem to kind of move in a way that's not obvious. You know, it, for example, they rarely run into the walls. They will like go through a door, for
Hmm.
example. But that may be just because air currents don't go through walls, they go through doors and it's following the air currents.
Mm.
So, the intentionality, people can ascribe intentionality to inanimate objects, and they're free to do that. But I think there's good physical explanations for ball lightning movement in terms of it being, a more or less neutrally buoyant object. If you
Mhm.
make a soap bubble
Mhm.
and have the right amount of helium in it and size, it's neutrally buoyant and it won't tend to rise or fall.
Mhm.
And it'll still move because there's always slight air currents unless you're in a very specially controlled environment. And so if ball lightning is literally as light as a feather or lighter, it's not surprising that it would drift around through openings just like air currents would.
Are there altitude restrictions to the sightings?
Well, I'm not aware of a lot of ball lightning sightings on mountains, but of course, mountains are various heights.
Mhm.
I think there are a few. Uh, Ball lightning has been sighted inside aircraft numerous times. Of course, the air pressure inside an aircraft, if it's a pressurized aircraft, is higher than the pressure would be outside.
Mhm.
I've read at least one theory claiming that ball lightning is much more common at high altitudes, but
Mhm.
there's no way to disprove that unless you fly around a lot waiting for ball lightning to happen. So there's probably not a strong altitude dependence. The air itself is not capable of sustaining the kind of plasma we have at sea level higher up because uh, the nature of electrical plasmas depends critically on the air pressure.
Mhm.
Uh, in fact, very high pressure air is a good insulator. It's very hard to
Mhm.
get any plasma to happen at all. In very low pressure air, the plasma kind of spreads out and gets diffuse.
Mhm.
You've probably heard of these phenomena called sprites,
Yes.
which occur at the tops of thunderstorms. And those ball lightning is kind of in the pre-sprite era in the sense that once people actually got a video of a sprite, a genuine research program took off and people could
Mhm.
start doing it. Well, we haven't had our genuine video yet, but sprites are discharges into the very low pressure upper atmosphere. And so you can have these huge bands of glowing uh, air
Mhm.
uh, because the pressure is so low. So the altitude would affect basically the nature of the plasma. So you probably can't have the same kind of ball lightning at 20,000 feet that you would have at, sea level.
Mhm.
But I'm not ruling it out. There's some kind of phenomenon like that might be going on.
Your 2025 paper on the Bozeman footage that it was not ball lightning.
Hmm.
Um, w-
Probably
that
not
that
ball.
that really impressed me, and I wanted to ask you, what does a rigorous negative result reveal about the methodology of this field?
Well, I mean, I can't say anything about the methodology in general.
Mhm.
I can say a lot about our methodology,
Mhm.
which was that we, thoroughly studied the video. We had high hopes it was ball lightning initially. We wrote up the paper saying we were pretty sure this is ball lightning, and then we sent it to some really high reputation reviewers. Dr. Sonnenfeld has some personal connections with other conventional lightning researchers, and I'm not saying, well, let's just put it this way, that we're pretty sure the reviewers we had were very good conventional lightning researchers, and they were very high integrity. And they said, we don't think this is ball lightning for the following reason. And we took a second look at it, and they said, well, they're right. um, I won't go into too much detail, but there were some artifacts on the original video which mystified us at first, but which turned out to be the clue that told us it was probably just small burning metallic fragments from an electrical arc on a power line. And we knew a power line was nearby, but we weren't sure how connected it was with the phenomenon until we followed this path that the reviewer suggested, and sure enough, they were right. And so my considered best educated guess of what that was, it was small burning metallic fragments from a power line arc, which looked like ball lightning because very sensitive security cameras tend to do what you call bloom. The actual bright object seems to be larger than it really is. And that's what made them look like ball lightning size objects.
Can you tell me about your magnetic monopole hypothesis?
Oh, I can tell you about it. I am not going to stand behind it 100%.
Sure.
Over the 20 years I've been doing this, I have, as I've been putting it, fallen in and out of love with a number of theories. Right now, my main squeeze is the magnetic monopole theory. Let's put it that way. The thing that makes this particular hypothesis, or something like it, at least worth considering, is the fact that numbers of people have been inside closed rooms and witnessed ball lightning either appearing right in front of them or disappearing. And there's a fair amount of energy that's necessary just to make a 100-watt brilliant object run for a few seconds. It's the order of 100 joules or something. Now, 100 joules is not a lot, but you put 100 joules in a firecracker and it's a firecracker, it's a small firecracker maybe. And the question is, how does that energy get into a room? Any kind of explanation, and there's been a lot of theories which start with a conventional lightning stroke to ground and, take a piece of that energy and do something with it that creates the ball lightning. That's fine if you're outside and within, however few hundred feet or however close you need to be to a conventional lightning strike. But there have been cases of ball lightning which do not seem to occur simultaneous with a lightning strike, which have been, possibly miles away from the nearest lightning strike. And nevertheless, there it shows up. If we believe in the conservation of energy, and there's no reason not to at this point, that energy has to come from somewhere. I found I won't go into the details of how this came about, but there was a reason that made me think that magnetic monopoles could at least have enough energy to account for the energy that ball lightning expends. The thing, magnetic monopole, by the way, for those who don't know it, is a hypothetical particle. Nobody has ever observed one. They may not exist. But if even one exists in the universe, it accounts for the discreteness of the electron charge, as Paul Dirac showed in the 30s. Don't ask me to explain that, but he showed it. So, people have been looking for magnetic monopoles off and on for a long time. There was sort of a fad of doing this in the 1980s, and it's since basically died down, and there's only one or two places in the world looking for them now. A colleague of mine named John Ralston, I hope he doesn't mind me using his name, we're working on a paper to talk about, how you could actually look for magnetic monopoles. It's possible that they can decay. The theory says that they may be very massive particles, and very massive means as heavy as perhaps even a small bacterium or something. Now, bacteria are not heavy, but compared to a proton, they're really heavy, and there's some unique properties of an extremely massive particle that would, for example, even if it loses 1% of its mass in some kind of interaction, that would be enough energy to account for the energy release of ball lightning. And the nice thing about this is if magnetic monopoles are either sitting around and get kicked out of the dirt by a lightning strike, they could travel a long distance. And they're so dense that they could penetrate, a few inches of wallboard or something and get into a room.
Hmm.
And if they have a nuclear interaction inside the room that makes them decay a little bit, then you could have this release of energy. So I hope I haven't mangled that too much, but that's the
No,
basic theory of the magnetic monopole theory,
I
which is
read a
not
great.
original to me, but we've picked up and run with it.
I think it's fascinating. I read a great deal of science fiction growing up by a gentleman named Larry Niven,
Ah,
where he based the entirety of their fusion power on magnetic monopoles that were mined from asteroids in the
all
asteroid
right. Well,
belt.
good for him. Yeah, yeah. There's
Um,
always hope.
oh, let me ask you if you can fix the fiction for me. When he wrote about it, he talked about it as if they were a volatile particle that require, they had, after the Big Bang in his stories, they had settled, this is of course fiction for the audience, but they had settled, the summit had found their place in the center of asteroids and found equilibrium there. These would require magnetic containment to maintain. Is that right? Is that why they dissipate? Because there's no boundary to it? Or,
Well,
if that monopole is what we're looking at?
let me straighten that out a bit. A
Sure.
magnetic monopole has a unique north, for example, or south magnetic charge, which again does not occur in nature as we know it. Every magnet has a north and south pole, and you cut that up. Well, those two little magnets have a north, you can't get to just the one,
Right.
because there are no magnetic monopoles that we know of yet.
Mhm.
A magnetic monopole, on the other hand, would be a single magnetic pole. It turns out that the force you could exert on such an object, if it has like just a single magnetic charge, and again, Dirac figured out what the unit of magnetic charge would be.
Mhm. Mhm.
It's large in terms of atomic or nuclear physics, but it's not large absolutely. And so it turns out pulling around magnetic monopoles with magnetic fields is not terribly efficient.
Mhm.
You need a huge amount of magnetism to do anything with them.
Ah, okay.
Now, on the other hand, it makes them very easy to detect compared to almost any other nuclear particle because you make a loop of wire. If you put a regular magnet through a loop of wire, you'll get a positive pulse and negative pulse, one for the positive pole, one for the negative pole. If you put a magnetic monopole through a loop of wire, you'll get a shift and it'll stay there. If it's a superconducting loop, I should mention
Mhm.
that.
Mhm.
I don't want to get too abstruse here, but there are uh, current devices called SQUID detectors, superconducting quantum interference detectors, which would easily detect magnetic monopoles. There was a fellow, I believe at Stanford, around the 80s, who on a Valentine's Day actually found data that exactly matches one magnetic monopole going through his system, but
Mm.
it never happened again.
Mm. Huh.
So, maybe there is, maybe there isn't.
The
But
wow signal of monopoles, I suppose.
you're right. Yeah, who knows? But so there are fairly easy ways to detect them if they exist. Like
Mhm.
the idea we're working on is you concentrate them in some object and then run the object through this loop. And if there's a magnetic monopole anywhere in the object, you will get this signal, and so
Mhm.
you'll definitely know you got it. So that makes them attractive to detect. But again, the theory of how many there are or whether there are any at all is very uncertain at this point.
Would they, by nature, be a quantum black hole?
No, they're not black
Okay.
holes.
Okay.
They're complicated. And again,
Mhm.
I'm not a quantum physicist. I'm not a
Sure.
nuclear physicist. All I know is what I read in the Scientific American and a few other places.
Mhm.
But uh, they're not a black hole. That's
Okay.
definitely the case. They would attract conventional nuclei to themselves, but simply because they have a high magnetic field close to them. And many nuclei have a magnetic dipole. They're little
Mm. Mhm.
equivalent magnetically to bar magnets.
Mhm.
And so you can imagine bar magnets being attracted to a magnetic monopole. And so there'd be probably a few sticking around them and they'd be hard to pull off. but it wouldn't just keep going and going because the field gets weaker farther away from the pole, magnetic monopole, and so they'd pick up a few, but that's about all. They are not black holes.
You've said that UAP and ball lightning research need the same sensor infrastructure and the same analytical rigor. How long have
Hmm.
you held that view, and what has kept it from gaining traction, do you think?
Money has kept it from gaining traction. I can answer the last question
Mhm,
first. There's a gentleman, I can't remember his name right now, but he's up in the Northeast somewhere. He has proposed a design for a sensing station
mhm,
that would have, high sensitivity cameras, telescopes, various kinds of nuclear and conventional radio frequency sensors. And unfortunately, each one of them would cost about $1 million.
mm,
And there's just no sales pitch anybody can come up with that
mhm,
convinces people to build and run $1 million sensing stations on the very small chance that they're either going to pick up UAPs or ball lightning. So that's what's preventing it. The technology, it's getting cheaper all the time. Uh, we proposed, Dr. Sonnenfeld and I proposed really a small version of such a station to the Air Force. And that year they didn't have any money, but
mm,
there's always hope. Yeah, it's something that amateurs can do on some basis. For example, there's wide-angle cameras that people can use to look at not asteroids, meteorites.
mhm,
And it could cost maybe $1,000 to build one of those. And so we're getting close to the area of citizen science, but
mhm,
not yet. To do it really right to where if one came into view, you would have enough objective evidence of different kinds that would convince the scientific community. You do need to spend on the order of $1 million for the monitoring station,
mhm.
unfortunately.
Have you, in the course of your research, you've collected over 1,000 eyewitness accounts via the form that you created?
That's a raw account because
Mhm,
not every report is really ball lightning, but yeah, we do have over a
right.
thousand reports. Yeah.
And within that, is there a crossover with what people might call the UAP community, or do you think that there might be ball lightning data hiding within UAP archives, maybe mistaken
Well,
for something else?
I'm sure there probably is ball lightning data in UAP archives. I got a report just the other day from a fellow who has just got involved in one of the UAP research organizations that I hadn't heard of before. Uh, I don't think what he was reporting to me was ball lightning,
Mm,
but it could have been.
mm,
Uh, I think there's enough familiarity with ball lightning on the part of dedicated UAP researchers
yeah,
that they will recognize it as such and reject it as whatever UAPs are, you know. Uh,
yeah.
and within our data set, there's a lot of observations that are so far away and so sketchy in details
Mhm,
that it's impossible to make any kind of a judgment based on the available information as to what it was.
mhm,
So it could have been a UAP. It could have been ball lightning. It could have been a distant, cargo jet landing in Nashville. It
right.
could, it could have been a planet. You know, eh, and those kind of reports are not terribly useful for the
Mhm,
lack of detail. Uh, we have never received anything that made me think, "Oh, gee, we gotta go tell the UAP people about this." Because, our we have some description of what ball lightning is on the website.
mhm,
And so if people if there's details that don't seem ball lightning like,
mhm,
from voices to face or whatever,
mhm,
that are uh, more in the UAP direction, I don't think they're even going to let us know. They're going to
mhm,
go to the UAP reporting websites. I'm sure there's many of those too.
mhm. In the field, there's a term used uh, quite a bit, and it's orb,
Mhm.
and it tends to conflate a lot of different things. I'm a skeptical believer. I'm an experiencer myself, but spending 20 years in the military, and in the Pacific Ocean, I've seen quite a few things floating and flying and et cetera, and am very familiar with aircraft. So, though I don't like the word debunk, I can debunk a lot of the videos that I see every day
Mm,
easily, whether
mm.
they're aircraft on approach or with a possibly incorrect lighting pattern, et cetera. But I've also seen what is described as a silver orb in broad daylight. And I'm positive, based on my experience, that what I was observing was not a mylar balloon or anything, any conventional explanation that I could come up with.
And this is a personal observation, not a video?
It's personal. I have a
Okay.
photograph of it.
All right.
I was
Mhm.
able to take one photograph of it before it departed the area. It departed in the direction it came from at speed. Um, but at night in the desert, I've also seen what people would describe as luminous orbs moving through the canyons or overhead, etc. And all of these things end up getting conflated in my community. I think that we may be looking at different phenomena or different origins of similar phenomena. Perhaps some are plasma based, perhaps some are 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 not. I guess what I'm trying to say is that how can we get past the ambiguity of shape
Well,
and things like that when we're dealing with
yeah.
a spherical luminous object?
Yeah. Well, all I can recommend is if you're interested in a particular location or a particular observation,
Mm,
you have to study it exhaustively, and
mhm,
that's a lot of work.
mhm,
Um, we get a lot of reports. And plus you got to consider the fact that there are what I'd call self-sustaining communities of belief. Let me
mhm,
put it that way.
mhm,
People want to believe a certain thing, and they go around and they find what looks like evidence, which they do not look at real hard,
mhm,
and they say, ah, here it is.
mhm,
When you say the word orb to me, my impression is, and I think I've seen websites along these lines,
mhm,
there is a situation with infrared security cameras that have a camera, and then right around or surrounding the camera, there's some bright infrared LEDs. You
mhm,
can't
mhm,
see infrared, of course,
mhm,
but there's a very bright amount of infrared illumination very close to the camera. Any kind of particle that's bigger than a few microns even, dust particle, a floating, spider web, an insect, if it's very close to the camera and it gets within the illumination area of these LEDs, it'll be out of focus, and therefore it will look circular, and it will not be identifiable, and it will float through the field of view. It's very easy to find these kind of objects on video cameras. If you're standing right there looking at it, you might not see the object that's causing it. And so I think there's a whole community out there who have taken these security camera videos, which have objectively the explanation I've just given you, and said, ah, here's another picture of an orb. What does
Yes.
it mean? you know, uh,
We
which
went
is
through
one
the same
reason I
thing with
think, go
I'm
ahead.
sorry. Oh, we went through the same thing when digital cameras first came out.
Yeah, yeah, right.
There was a
There's
lot
all,
of research, there were whole books written on it,
yeah,
and I'm with you. I have people write in my comments or write to me and saying, "Did you see the orb?" And I say, "No, I have a very dusty studio."
yeah,
It's
right. There you go.
I know
Yeah,
that's dust.
yeah.
Um, yeah,
And so I think the word orb is probably a very limited use scientifically
mhm,
anymore. Let's put it
agreed,
that way.
agreed.
Uh, but if a thing does have a round shape, you can call it an orb. It's in the vocabulary, but it's not helpful, and it will has a lot of connotations which are not going to be scientifically useful. Let's put it that way.
Appreciate that. Um, when I was on board the USS Princeton, the Spy 1B radar tracked the Tic Tac. We had multi-platform sensors, some of which are still classified and or the data is now missing. But we didn't close out the question of what we were looking at. And I wanted to ask you, what does that tell us about what sufficient evidence looks like when you can have a multi-million dollar asset with incredible technology focused on an event and perhaps still not be able to gain what you need to understand what you're looking at?
Well, sometimes that happens. I found a book on radar by the Hughes Aircraft Company, published about the time I was working there one summer, 1980, years and years ago, which made me at least wonder about whether radar, at least if radar evidence is used, uh, whether it's even possible, given resources enough, to figure out what could have caused a particular signal. And this was true, 50 years ago, and I'm sure it's even more true now. The image that is presented to the pilot or whoever's, looking at the actual image is a highly processed thing. And the old days of when, whatever came into the radar more or less appeared immediately on the screen, a blip was a
Mhm.
blip, that's not the case anymore.
Mhm.
Uh, So anybody trying to figure out what was actually causing a particular signal must be, I would say, intimately familiar with the entire processing system and know what would cause which and what kind of signal would cause this sort of thing and so forth.
Mhm.
And I don't know if anybody with that degree of knowledge of all the systems you were talking about has ever looked at that data with the point of view of, okay, what sort of an object would cause this in terms of, these DBZ numbers and the technical reflectivities and so forth. Now, I don't know anything about, you're obviously one of the experts on the Tic Tac situation, and I'm not. You were there. Uh, but based on our silly little limited experience with the Bozeman thing, and it took us the
Mhm.
better part of 2 years to figure that out.
Mhm.
Of course, we have limited resources, but even simple things that look obvious, you really have to study them very deeply in order to eliminate truly all conventional explanations, or at least the conventional explanations that you could find out. And you have to have friendly reviewers that hold your feet to the fire and so forth. Uh, But again, if you don't have enough information and it's not possible to get more information, you simply have to decide to be undecided.
Mhm.
You have to accept ambiguity in this business because you'll go crazy if you don't. And it would be nice to have more, but all of us have limited resources, and unless we can convince some powerful people to uh, deliver more resources to this field, expend it appropriately, whatever that means,
Mhm.
we're just going to have to, work on what looks most interesting and promising and try to be as thorough as possible when we do.
Some researchers, specifically skeptics, will just say that many UAP sightings are atmospheric events. Um, I'm not looking for confirmation bias, but I'm looking for you. Can you tell me how likely that is? Are there atmospheric events that would mimic what people are describing when they describe UAP?
I read a wonderful book, and if I had written down the name of the author, I would tell it to you right now. He was an astronomer writing in the 1950s during this flying saucer scare. You probably know his name.
Mm,
I think flying saucers, I don't remember. The
mm,
flying saucer phrase is in the title.
mhm,
But he was doing the same sort of thing I do with ball lightning. He was and he was qualified. He was, I believe, on some of the committees that were in charge of sifting through the flying saucer reports, Project Blue Book, and so forth. His name would come up in those circles. He wrote a whole book, and debunking is a harsh word, but
mhm,
explaining. I would prefer explaining a huge variety of reports of flying saucer-like phenomena, which initially were very convincing. The most interesting mechanism to me in that book is what atmospheric refraction can do to planets
mm,
near the horizon.
mhm,
Uh, I'm actually looking at that with connection with some other stuff. But if you have enough air between you and the object, and toward the horizon, you're talking about miles of air sometimes,
mhm,
and you have a temperature inversion where the index of refraction, which depends on temperature, varies in a complicated way. You can do almost anything with an image. You can make it bigger, you can make it flat, you can make it look like a flying saucer, and it'll wiggle around, it'll move. And you look in that book, he has several cases of very sensible people there, fighter pilots and so forth, who saw these things, chased them even, until they couldn't find them anymore.
Hmm.
And he goes through the astronomy of what was where and whether there's a temperature inversion, and finds that the best explanation was that was Jupiter looking through miles of air, and it was doing really weird things to the appearance of Jupiter. So yeah, I think, if somebody put the kind of energy and intelligent research into many UAP cases uh, that he did, you could probably find that there is a conventional explanation to many of them. Uh, I'm not a universal skeptic. I remain open to the possibility that some things people see cannot be explained by science in principle,
Hmm.
and that's fine. But when we can explain them with science, conventional science, I want to do that first before, I jump off the deep end and think of something more exotic.
I think you present a very humble and pragmatic view of being open-minded while sticking to the rules, so to speak.
Yeah.
Does the scientific method have a permanent blind spot for the real but not yet reproducible? Is there a way that we can transcend the system that we have to open up those things that humanity sees collectively but can't prove individually?
That's a big question. uh, I'm a Christian, and I believe God created the universe. And of
Mhm,
course, there are many things in this universe we don't understand. God understands all of it because he made it. Uh, and so, given that philosophical and theological set of assumptions that I make,
mhm, mhm,
uh, science has a limited uh, remit.
mhm,
It can explain certain things uh, that are observable, uh, and reproducible and so forth, but it cannot explain the universe as a whole. It cannot explain why we're here. It cannot explain the unreasonable uh, applicability of all sorts of mathematics to explaining the universe. There's many physicists who, I know this math applies, but I don't know why it,
mhm,
and so forth. Uh, so there, it, I don't think we need anything new. Let me put it that
mhm,
way.
mhm,
Uh, I think we need to keep in mind the proper uh, duties of science, and there's plenty of things for science to do.
mhm,
And my attitude toward any phenomenon that anybody tells me is, first, is there a scientific explanation? Now, that doesn't, I'm not I don't believe in scientism, which is
mhm,
the idea that science can explain absolutely everything, including
mhm,
us. But I do want to start with science
mhm.
because it's a very powerful intellectual tool, and it can explain a lot of things we don't understand. That's how we got where we are. But at the same time, I don't want to, uh, you know, ignore things that people see and trivialize them or say that they're crazy or something simply because I can't explain them scientifically. That's not fair either.
I don't recall where I heard it, but I recently heard someone describe science as what happens when philosophy grows up and starts paying attention to the data. Um,
Well, they're not a philosopher, I don't think.
but at the same time, I tend to agree to a certain extent. A lot of sciences, were born from original philosophies that where the evidence was scant or we
Hmm.
hadn't reached a technological level where we could even notice or collect it. But I have to say that it's wonderful to talk to someone who has an imaginative mind as you do and is willing to talk about the edges and the assumptions and the that might be made by people. There seems to be today in the hard sciences a a certain lack of a philosophical bent or the same level of curiosity that led the people that established these sciences
Hmm.
into action. I'm quite impressed with the way that you present yourself and the body of work that you have. I have to ask you, unlimited resources, the right collaborators, and the right location. What does the Karl Stephan ball lightning experiment look like?
Well, first I'd hire a really good manager because I don't like managing stuff. Uh, yeah, I think several of these $1 million observation stations in likely places. By likely, I mean where the lightning is pretty frequent. Uh, there's a hot spot in northern Florida and another one in border between Louisiana and Texas. I think that would go a long way toward giving us a chance to have enough data on ball lightning to actually make a long stride toward explaining it.
Mhm,
Either that, there's always this nasty little possibility, which is that ball lightning is a collective groupthink thing that, again, if you had infinite resources and tracked everything down to what it, really was, it's just a bunch of miscellaneous conventional stuff. That is a logical possibility. But, you know, I find that these days in the United States, hardly anybody under 40 or 50 knows what ball lightning is.
right.
And that's a good thing in the sense that if we get reports, they're not biased by, oh, I know about ball lightning and I bet that was ball lightning. No,
Mhm,
they don't know what they're doing. They see something first. They go out on the internet and I saw this, and then the word ball lightning comes up.
mhm,
If it was a groupthink where ball lightning was kind of a folk myth or something, and
mhm,
then every now and then we see something and we call it ball lightning, well, yeah, maybe that would be an explanation that would account for phenomena that are really something else. But it's just there's too many people in too many places at too many times in the history of science and even before that has seen similar things that I think really do happen. And, if you had enough instrumentation there, you could figure out what it is. But we never have, up to this present time, have had enough instrumentation. And, it's encouraging that people carry millions of phone, high quality cameras around in their pockets. But the time it takes to pull it out and get the camera going is about the lifetime of all life. And
mhm,
so that is one reason we haven't got more. There's security camera footage somebody sent us a few months ago. They had a security camera on the front door and one on the back door. The camera on the back door caught the light from the ball lightning object that the guy saw personally, but the front door camera was busted.
mhm.
So, we were that close. Uh, but yeah, if we had enough monitoring stations in places that it's likely to show up, statistics at least tells us that sooner than later, and the more resources, the sooner it would happen, we would get some kind of an image that would very likely be act like ball lightning, and then we could look at radiation and spectra and whatever, and maybe make progress toward figuring out what it was. But it takes several times, and it
I
would
hate to
also
do
take a lot of time finding out whatever else is going on first and then getting rid of that, which is something that people neglect. They think, "Oh, we'll put up something and catch it first." No, first you gotta find out for years what else you're seeing and figure out what that is, then you'll know what to look for.
Mhm. I hate to do this to you, but, you've got a hypothetical venture capitalist billionaire sitting across the table from you, and he says, "Doc, why do I care if we find out what ball lightning is?"
Yeah. Well, if the energy is nuclear, there is a potential energy source there that
Mhm,
it weighs virtually nothing, that puts out, a watt or 2 for a few seconds, and if it's 1 nuclear particle, this could be commercially exploitable. I'm not the first person to have that idea,
mhm.
but, there's a small chance there's new physics, and there's an even smaller chance that the new physics could be commercially valuable. Those are 2 very small chances multiplied by each other. Uh, and then there's just the old scientific, I wanna know, that we used to have more of a culture that was, attracted to that idea, but we live in an extremely pragmatic age now, where if you can't either show a return on investment in 3 years or, how it'll save people's lives or something. And then there's nothing wrong with saving people's lives, don't get me wrong.
Mhm.
But unless it has some near-term practical application that fits in with our cultural desires and not just, just to know it, it doesn't have much traction these days.
I really appreciate that view. Um, where can people support your research? Is there a portal or any way that they could help you out?
Well, no, not financially.
Mhm.
If they know of anybody, first of all, talk about ball lightning. Tell
Mhm.
people, "Hey, I heard this crazy guy talking about ball lightning the other day." At least let them know what it is.
Sure.
Uh, I'm not gonna read the URL of our, report site. I hope you could post it
I'll put it up.
afterward.
You bet.
Yeah, you know what it is.
Certainly.
But we
Certainly.
have a ball lightning report website, which has a pretty detailed questionnaire that asks a lot of questions the other places don't. And when somebody's answered our questions and given a little narrative of what they saw, we have the chance of having very good data, from an observer.
Mhm.
So, inform people that there is such thing as ball lightning, at least some people think so. And if you ever see it or know somebody who's seen it, get them to send a report in and answer the questionnaire. So that's really the support we could get now. If you happen to be a billionaire with looking for something to do with your money, I can talk with you. Believe me, I'll find time to talk with you. But other than that, yeah.
So what's next for you? You have any speaking engagements coming up or
Not speaking engagements as such. I have a student who approached me, actually, an undergraduate student, who is working on analyzing our database statistically, which we've
Mhm.
never done in any sophisticated way. And I have hopes that that will show up. We're looking at things like correlation with conventional lightning and correlation with other things that have a small chance, but you never know. But we have enough data now that we're starting to be able to actually say some statistically meaningful things about the data. And so we're working on that this summer, and I'm hoping that we'll have some publishable stuff out of that. Uh, I'm I we're working on a magnetic monopole related paper, which may eventually get published. So those are the main things. I'm working on some other stuff having to do with atmospheric phenomena in general. That's about all I'm doing at this point. I'm semi-retired, so I teach one class a semester and have more time to do this kind of research. So I'm looking forward to that.
Well, I really want to thank you, not just for today, for coming on the podcast and talking with me or your patience leading up to this recording, but also for dedicating your life to teaching the rest of us about something that we might not otherwise have seen or understood. I have an incredibly large place in my heart for people who continue to study and share their data with the rest of us instead of turning that into a patented reason to keep a secret. So, Dr. Karl Stephan, thank you for coming on the experience today, and I hope we can have another conversation sometime soon. I'd love
Thank
to
you for
talk to you
having me.
after the new research is in.
Well, thank you for having me. I very much enjoyed it. Great.
Thank you.